Hello everyone. In this video, we have to see about the some of series on the semiconductor lasers productions. Now we have to see about the previous class. We have seen the some of the carbon dioxide gas or molecular gas laser. In this video, we have to see about the homojunction, that is semiconductor laser. So what is the type means? It is a nothing but it is a p-type and n-type semiconductor which is used to produce the laser action. So type will be homojunction and heterojunction. Homojunction is nothing but p-type and n-type, the laser output coming from the any one of the end of the junction area. Another one is heterojunction. Heterojunction is nothing but there's a different type of layers, p-type and n-type layers, which will be involved in the production of laser light. So these are the main three components. We have already discussed about the components of the laser lights. So first we have to see about the what is the type homojunction. Next, the active medium will be the p-type or n-type material. Then we have to see about the what is the activation center. Activation center is nothing but production of the laser light, which is light coming from laser light coming from that particular process. So what is the process? It means here it will be a recombination of electrons and holes is responsible for the production of laser light. The optical resonator will be used as a polished junction of diodes. Any one of the end of the diodes will be used as the optical resonator to enhance the output of the laser light. So power output will be minimum, so that will be 1 milliwatt will be used for various communication purpose. So what is the nature output? We can be able to produce the light as a continuous medium, a continuous light or a pulsed laser light. The wavelength will be in the range between the 8400 Armstrong units to 600 Armstrong units. So what is the basic schematic diagram of the video is the homojunction laser is nothing but this is this p-type and n-type region. There is electrode will be connected between the two junctions, so it will be connected by the potential, the laser light coming from the junction. So p-type and n-type will be there is a potential barrier. So that potential barrier is responsible for the laser action, that is achieve the condition for the population inverse condition will be achieved in that potential barrier area. So you can see the next slide. So this is the semiconductor laser barrier gap, potential barrier gap. It's nothing but gallium and arsenide will be used for the p-type type semiconductor. So this is the conduction band and will be the valence band. There is a p-type region and the n-type region. The electron get energy from the potential. So holes will be jumping from the conduction band, valence band to conduction band. There is a population inversion. There is a number of electrons in the ground state will be less than that of the higher state. That is the population inverse state. So we can once the number of electrons will be excited into the conduction band, there is a number will be increases compared to the ground state holes. So that's a recombination process can achieve. There is a certain recombination process, that is the population after achievement of the population inverse, there is a certain recombination process is accomplished. So that time the electrons emits the high laser produces the emission the radiation as high laser outputs. So that is the production of laser light behind the homojunction lasers. So you can see that what are the applications we have used for that specific application. There is a compact and optical fiber communication, CD writer and paints. Some of the medications laser will be used as the paints and laser printers. So next type is nothing but the heterojunction. It is similar to the homojunction laser. So PN is made up of different material, p-type and n-type. But the principle is recombination process relies from the certain specific. There is a band gap semiconductors. Semiconductor materials also called as a band gap semiconductors. So it is forward biased electron from the n-type holes and p-type region come with each other and produces the laser light. There is the same type. So only difference is there is a number of layers will be increased. That is the three types of what is it is recombination, heterojunction, that is a different type of laser lights, and active medium PN junction made up of different layers. That is in the one layer is the homojunction, different layer will be the heterojunction layers. So what is the direct pumping method to produce the electron get excited from the ground state, and power output will be 1 milliwatt. It is also 1 milliwatt. It will about it is enough for the production of the communication or the electronic devices. So nearly the wavelength nearly about 8000 angstroms. So they can see the schematic diagram of that gallium arsenide heterojunction, and it will be made up of another addition doping, that is nothing but gallium aluminum, and that's a n-type, different type of layers. First layer will be gallium arsenide p-type layer, and the third layer will gallium arsenide p-type and n-type, at which they induced with this aluminum. So aluminum is the second layer, and gallium or aluminum arsenide will be the n-type, that is the fourth layer. When third layer, fourth layer will be polished and parallel with each other. This is construct the overall construction of the schematic diagram of the heterojunction laser. That is that in between the 3 and the fourth layer will be the polished, that will be used as the optical resonators in this heterojunction lasers. So this is the again recombination process, same like that, but it will be there is a number of electrons will be higher than that of the homojunction. Because of the there is a lot of layers involved in production of the laser lights. So equally can be there's a recombination process, holes and electrons moving forward, electrons getting downwards transition from the excited state to the ground state, that is nothing but connection back to the valence band. That is the same process that emits the photons, that is nothing but laser lights. So this is the main applications. So there is advantage, it produces continuous waves. The output is very high. The disadvantage is very quick to grow a different layer, p-n junction layers. That is the one of the disadvantage, and the cost is very effective. So in this video I have stopped here about the semiconductor laser. A short note on the semiconductor lasers, that is nothing but homojunction and heterojunction. Next class we have seen with the another useful topics. Thank you.